Hello and welcome to the video number 3 dealing with stoichiometry. The first video we talked about what was stoichiometry, what is a mole, and how do we calculate the molar mass or the formula weight or the grams per mole. The second video we started to look at a chemical equation, and given that we had one of the reactants that was in excess, which means it wouldn't run out of, and we had one that would be limited, okay, we could go and calculate how much product that we're going to get. That was the second video. So if you went on this one and you haven't looked at the other two, you might want to go back and look at the other two just as a refresher. But if you're totally here dealing with the issue of limited reactant and how do you find the limited reactant, then, well, this would be the video for you to look at. First off, we have to look at, well, what do we mean by limited reactant? Well, in the real world, when you have companies that manufacture certain types of chemicals, whether it's fertilizers or whatever, they are going to need reactants. And part of the business is that they have to go and get those reactants, bring them to the plant, and then be able to run large-scale chemical reactions in order to manufacture the amount that they need so they can sell it to their customers. That would be chemistry in the real world. Now, in the real world, that means typically you're going to be running out of a reactant, one or the other, and usually what's going to limit how much product you're going to make is probably your most expensive reactant or the reactant that is much more difficult to get, to purchase from somebody else. But for us here, we're going to go ahead. We're in the water manufacturing business, and I want to show you how do you sit down and calculate how much product are you going to get based off that you have two reactants that we do have a finite amount. In other words, we have an amount that will run out. None of these are in excess. It's really a big deal. It's not too bad. You need to do a little bit more work in order to find out which of these two reactants we're going to run out of. So let's go ahead and let's go with the basic idea. 2H2 plus O2 gets us 2H2O. That's our basic balanced equation. We have 2 grams of H2 gas, hydrogen gas, 32 grams of O2 gas, oxygen gas. And we're trying to find out how many grams of water are we going to make in the process. Now, I'm looking here and I'm looking here. By looking at this, I can't tell how much water am I going to make just by looking at this. I can't. So I've got to figure out, I need to know how many, what is the number of moles of hydrogen gas and the number of moles of oxygen gas, because then I can go ahead, plug that in, and find out how many moles of water that I'm going to get. And then go from moles of water to grams of water. That's the basic big picture, okay? So let's take a look at this here for a moment. So our first step that we would need to do in order to look at this, we need to go from grams of hydrogen gas to moles of hydrogen gas. That's what we're looking at. Okay, and I'm going to do this in red, okay? Now I'm going to go under the assumption that hydrogen, I don't know if you can see it, is 1 gram per mole, and that oxygen is 16 grams per mole. I kept the numbers small on purpose so that the numbers are very easy to work with and that you guys can see. What's important is that you understand the process, not the numbers necessarily, but understand the reasoning, how do we go through, because that's where I'm trying to spend the time with you guys. We need to change this from a mass into numbers, because that's the only way. It's like changing, I have so many kilograms of rubber. How many tires am I going to get out of this many kilograms of rubber? How many grams of hydrogen? I need how many moles of hydrogen? That's going to make sense for us. So let's take a quick look here. And we're going to go from grams to moles. If we go from grams to moles, well, all right, that means that we're going to divide. Okay, what are we going to divide? Well, we're going to divide. We're going to take our 2 grams that they gave us here, and we're going to divide that by let's see, it's 1 gram per mole for 1 hydrogen, so it'll be 2 grams per mole of hydrogen gas. Okay, notice I included the units here so that you guys can see that, and I end up getting 1 mole of hydrogen gas. Okay, that's fine. Now, the next trick is, we got the number, because remember, a mole is a number. We got 1 mole of hydrogen gas, and now we're going to go into moles of water. So we're looking at the numbers of hydrogen gas. We're going to figure out the number of moles of water that we're going to get out of this. Okay? So we are assuming here, working with the hydrogen, that the oxygen is in excess. It's unlimited for now. This is, we're doing 2 possible things. We're going to look at hydrogen as our only reactant and oxygen's in excess. Then we're going to flip it. We're going to do the other way, where we're going to figure out oxygen the same way so that we can figure out how many moles of water we get. So let's go ahead, and I'll still go ahead and I'll work in red to show you guys. So now we need to look at the ratio. If I have 1 mole of H2 gas, I have no idea how many moles of water I am going to get as a result. But there is something I do know. I have this. I have the coefficients right here. Now pay attention. This is the only time in the entire process of stoichiometry that the coefficients come into play. Okay? That's the only time. So right now, that means there's a ratio. For every 2 H2s we have, we're going to have 2 H2O. So when all is said and done, well, anything over itself is 1, right? So we are going to have 1 mole of water. This is using hydrogen gas. If we ran the hydrogen gas all the way through and we said that there's unlimited oxygen, that's what it would look like. So we would end up with 1 mole of water. Burning up the hydrogen, excess oxygen. Okay, am I going to go and figure out the mass of the water? No, not yet. Now I'm going to go to the second part. The second part is we're going to do the exact same thing, except we're going to do this with oxygen. Why? Well, we're going to assume that hydrogen is in excess this time. Hydrogen's in excess, okay, whereas here we assumed oxygen was in excess. Here we're going to assume hydrogen is in excess. I'm going to switch to a different color. I'm going to switch to blue, all right, and we're going to see. So what information do I have? I have 32 grams of O2, and there's 16 grams to 1 mole of O. So that would mean for us we have 32 grams of O2. They gave that to us at the beginning of the problem right here. Okay, that's where I'm getting my 32 grams. I'm also going to do the same thing I did up here. I'm going to go from grams to moles for oxygen. Now, I got 32 grams of O2. Now I need 32 grams of O2 to equal 1 mole of O2. So guess what? That's going to get me 1 mole of O2. Now remember, we're assuming hydrogen is in excess. Okay? This is why I did it in red here for the hydrogen gas. We figured how much we were going to get. And here we're going to figure out how much are we getting just burning up the oxygen. All right. Now, let's take a look at this. So now I've got mole of O2. Now I have to figure out how many moles of H2O am I going to get. That's the key thing. Because now we've got this number of oxygen atoms, I shouldn't say oxygen molecules. Now we got to figure out, hey, how many water molecules are we going to get? Okay. So now we know, let's move on down here. So we know that we have 1 mole of O2. I don't know how many moles of H2O I have. I don't. It is going to equal something else though. It's going to equal Now keep in mind, this is very important how you keep this. Okay? There is a ratio in the original equation. And notice now we're going back up here, and I'm interested in this coefficient, and I'm interested in this coefficient. Notice here I underlined in red. That's when we worked with the hydrogen. Here we underlined in blue because I'm only interested in this O2 and the resulting H2O. That's the difference. So now I can go in here. I know that there's a ratio, 1O2. Notice I didn't put a slash through there because it's the letter O. It's not the number 0. Now you know why. And we have 2H2O. That is our ratio. Now, let's check this out. We can go ahead and cross multiply and divide. Okay? Well, we can go ahead and cross multiply. Notice how my hands are. And then divide. That's the idea behind it. So, let's look through. And we're going to keep on going. We're going to say, all right, so 2 times 1 is equal to 1 times x. Solve for x. Okay? Well, in this case here, 2 is equal to x, which means we have 2 moles of water that's made. So, now I'm going to shift here. I'm going to extend the page. Because now we've done most of the hard work. We had to find out how much water was going to be made if we burned up the hydrogen totally and we kept the oxygen as unlimited excess supply, and we came out with 1 mole of water. All right? That's what we got. We did the same process for oxygen. We said hydrogen was unlimited, it's excess, so we're going to burn up that oxygen. And I end up with 2 moles of water. Okay. How do I know what's the limiting reactant? Well, I have 2 moles of water, assuming O2 is the limiting. Okay, that's one possibility. The other possibility, we have 1 mole of water, and that's with H2 as our limiting reactant. Okay? So this is what we have, ladies and gentlemen. Now the question comes down to is, all right, how do we know which one's the limiting reactant? The key thing is which one do you run out of first? That's the key. And the one that you run out of first means you're making less product. That's the key. Because here, we're assuming O2 is the limit. Unlimited H2, we would make 2 moles of water as our product. On the other side, we said unlimited oxygen, and H2, our hydrogen gas, is the limiting reactant. We only make 1 mole of hydrogen. 1 mole of water. Okay. So this is what we have. What can we conclude? What can we conclude? Well, there's a couple of things. Number 1, the smaller amount of product is going to be the correct one. The smaller amount of product is going to be the correct one. Why? Because the H2 is going to run out sooner than the oxygen will. Is there any other way to calculate what's a limiting reactant based off of what we looked at before? The equation and the number of grams? No. You've got to work it all the way out here until you find out how much product do you make. So this is it, ladies and gentlemen. This is our final thing. So now what we can see is our conclusion is hydrogen is the limiting reactant. So that's going to run out first. That's going to run out first. Now, okay, so now I have 1 mole of H2O equals how many grams of H2O. We got to rapidly wind down here. Okay, so now we're going from moles to grams. If we're going from moles to grams, guess what? You multiply. So we're going to multiply. Okay, well, what are we going to multiply with? Well, we have 1 mole of water. We are going to multiply that times, well, there's 16 grams to 1 mole of oxygen, 1 gram to 1 mole of hydrogen. So 16 plus 2 for the 2 hydrogens equals 18, so that's going to equal 18.00 grams to 1 mole of water. Now, check this out. The moles of water cancel each other out because anything over itself is 1. Yeah. So what are we left with for our final answer, boys and girls? Our final product, our final thing. This is it, ladies and gentlemen. For all that trouble, we are going to manufacture a whole whopping 18 grams of water. Woo! Yeah. What a way to go, huh? All right, ladies and gentlemen, this concludes the video. We talked about the idea of what is a limiting reactant. We talked about the procedure to find out which reactant would be used up first based on the least amount of product that's made. That's the key thing. And with that, ladies and gentlemen, I hope this video has helped you out. Okay? I believe this is going to be the last of my stoichiometry series. All right, take care and have a good one.